Often in counting techniques, to solve a problem we're expected to know when to add or multiply numbers, and sometimes it's not entirely clear. So let's have a look at some guidelines to help us establish when we actually go through with multiplication and when we do addition. In this first example, we're asked to find out how many 4-digit numbers there are starting with an odd and finishing with an even. Now the key word there is AND. That means that these two things must occur together. So we can determine the number of arrangements by looking at the first place and saying that there's 4 digits that could go into there, and there's 4 digits that could go into the last place, which is where the even digit must be. But in doing that, we've used 2 digits. So the number remaining is 6 for the second place and 5 for the third place. These numbers are then multiplied as the two aspects of this problem, in other words starting with an odd and finishing with an even, must occur together. In our next example, a similar situation occurs in that we've got 4 letters from the word west, but they must start with a W and end with a T. Again, the key word here is AND. They must occur together. So in the first place, there's only one character we can have, that's a W, and the last place there's only one character we can have, and that's the T. And that means that we've got 2 remaining characters, the E and the S, and they must go into the second place, and once one of those is used up, there's only one remaining to go into the third place. And again, we multiply these together. In this next example, there's a subtle change in the wording. We're being asked to find 4-letter words formed from the word west, starting with a W, or starting with a T. Now, we can't have words starting with a W and at the same time starting with a T. So these two events are said to be mutually exclusive. They can't occur together. And because of that key word there, or, it is possible for this to occur. If it had said start with a W and start with a T, there'd be 0 possibilities. But because it says or, we can actually go through and investigate all of the words starting with a W and all the words starting with a T. We can see here we've actually listed all the possible words starting with a W and how you'd calculate it, and that's shown in brown. And shown in purple is all the words starting with a T and how you'd calculate it. In each case there's 6 possibilities. So overall there's 12 ways that you can start words with a W or start it with a T from the original letters of the word west. In this next example, we can see that we are asked to start words with a W or end with a T. So the word or means we need to consider all possible cases. They don't have to occur together. But because it's starting with a W or ending with a T, it is possible that we could have a mixture of words that do start with a W and end with a T. These two events are not mutually exclusive. And this is a little bit more involved now. And we can see from this next picture that we've got some possibilities of words that start with a W. They're shown in brown. We've got some words in light blue that finish with a T, but also in green you'll see some words that actually start with a W and finish with a T. So the problem becomes a little bit more complex because what we have now is a situation where we can add together all the possibilities, but because we've got an overlap, in other words, words that have both features starting with a W and ending with a T, we need to go through and perform a subtraction because we've counted some of the words twice. Let's go through and look at some simpler examples in more detail. Our first example starts with a 3-letter word cat, and we're looking at how many words we can form in the first case starting with an A and ending with a T. Now the key word here is AND. In other words, these two things must occur together. So we can see from a simple tree diagram that there is one situation where you start with an A and finish with a T. Let's have a look at how we actually perform that calculation. When forming our 3-letter word, we know that in the first place there has to be an A. So what we do is we place a 1 there because we've only got one option. At the same time, we must end with a T. So there's only one letter that can go in the last place. So we put a 1 in that place as well. And in the final place, there's only one letter remaining, in this case a C, and that has to go into the middle. So our calculation for the number of words is 1 multiplied by 1 multiplied by 1, and of course that comes to 1. Now let's look at the same situation but with the OR. Now what we have to realize is that to start with an A or end with a T, these are not mutually exclusive because they can happen together. But the key word there is or. In other words, we have to consider all cases. In other words, starting with an A where it doesn't finish with a T, and likewise finishing with a T, but not necessarily starting with an A. So let's have a look at the first case, starting with an A. Now we know that we have to have the character A in the first place. Then after that, we've got two more characters, the C and the T, and we just exhaust them going left to right. In other words, 2 in the second place and 1 in the last place. Or we could end with a T. Now if we end with a T, what happens is that we have to have one character in the last place, that's a T, and the two other characters, A and C, in the first two places, hence the 2 multiplied by 1. But notice we're adding these together. And then what we have to do is consider the possibility of an overlap. In other words, are there cases where you can start with an A and finish with a T? And we've actually counted them twice. And that's occurred with the ACT. So we have to subtract that 1 times 1 times 1 because that's a situation where we do get A starting first and ending with a T. So the key thing to note here is that because of the OR, we had to work out the number of ways starting with an A, separate to the number of ways ending with a T, and then look at the possibility of an overlap, which occurred in this case because the two events are not mutually exclusive. When we do that, we find the total number of ways of starting with an A or ending with a T based on the 3 letters from the word cat comes to 3. Let's have a look at another example where we've got two sets of numbers, set A and set B. And we're looking at forming 3-digit codes that could be made from set A or set B. So the trigger for the OR indicates that we need to do some addition. So let's have a look first of all at set A. Now in set A there are 4 digits. There's no restriction other than the fact that they must be a 3-digit code and repeats are not allowed. So from A we can see that in the first instance there will be 4 digits for the first place. We've used up one of them, so it'll be 3 for the second place and 2 for the final place. Now what we do is perform an addition because we're looking at set A or set B. Now we can see from set B the same principle applies. There's 4 digits that can go into the first place, 3 into the second place, and 2 into the last place. But these two sets are not mutually exclusive because it is possible to have codes such as 3, 5, 7 which are common to both set A and set B. So the 3-digit codes that could be repeated are based on 3, 5 and 7, and we can see here in black that the number of ways of rearranging 3, 5 and 7 without repeating the digits is having 3 possibilities in the first place, 2 in the second and 1 in the third. So overall the number of codes that can be performed with 3 digits from set A or 3 digits from set B would be 42. We can see here in the list that those in red are those that are unique to set A, and those in blue are those that are unique to set B, and in black we have those codes that are possibly formed from both the numbers in set A and set B.